Hi, everybody. Here we are, day 2 of the VM workshop. And up next is our friend Mike Friesenegger, who's going to share with us some new things from SUSE. So over to you, Mike.
All right, thanks, Bill. Hello, everyone. This is awesome. I love the inner workings of Z-Pro. That was awesome, actually. The Z-Pro functionalities are awesome. From SUSE, we have an exciting announcement for customers and organizations that are looking at Kubernetes on Z and LinuxONE. And I wrote a blog about it, but I'd like to take this opportunity to tell you a little bit more about a Rancher, which is coming to IBM Z and LinuxONE. And actually, I'm super excited because this is going to be the first group to see a working demonstration of all of this outside of SUSE people that maybe have seen some of this. So I've tried to make this a lot of fun, jumping through not only some slides, but also focusing on demonstrations. So I'm not going to spend a lot of time, only 17 slides in total. I'm going to try and focus more on the demonstration, but we've heard this, and we're hearing it from IT industry leaders, we're hearing it from organizations, we're hearing it from just about everybody that enterprises will standardize on Kubernetes. 76% of enterprises will standardize on Kubernetes within 3 years. So with that in mind, like I said, I wanted to get going on the demonstration straight away. And one of the things I wanted to show off is Rancher, Kubernetes engine running on SLES, on SUSE Linux Enterprise Server on Z. And I thought I would start from a bare bones setup. So let me go ahead and get to I've got my cheat sheet just in case I need something, but basically I'm going to go ahead and log into a system. And I probably should have this prepared ahead of time, but I didn't. This is going to be my RKE2 server, and then I'll actually be adding. Now, these are just basically installed SLES systems. Nothing's they're registered. That's about it. I've copied the installation, the installation code for Rancher, but if I look at it, and we're on an S390X system, and I'm running on ZVM. Now you can run this on KVM. You can also do this on LPAR. You can mix match between LPAR, KVM, and ZVM. So pretty cool, but I'm going to do everything on ZVM today. I already have the Rancher Kubernetes engine executable installed. That was some of the prep work that I didn't want to take the time to show you, but I just copied that. And so you can see here is Rancher, the help screen. Let's go ahead and let's kick off the server. So this is going to take about 4 minutes to complete. When this is done, I will have a Kubernetes master node up and running. And we'll watch it for just a moment so you can see what it's doing. I have it set up in air-gapped mode, so you can actually start the install and do it over a network and pull packages from the internet, or you can actually copy everything down locally to another system and then copy it up to your Z instance and start the install. So we're not going to, it'll show up some errors and things like that because it's in the process of basically watching all of the services, the Kubernetes services to come up. So we're not going to watch all of that stuff and wait for all of that. We're going to go back over to the presentation, and I'll come back to this in a few minutes, and we'll actually see that we have the Kubernetes master running. It takes, like I said, about 4 minutes to get that done. So let me take just a moment and talk about why Kubernetes. We've heard a lot about Kubernetes, and so you may already know some of this, but I just want to do a quick level set. Is that Kubernetes enables a common compute platform across any infrastructure, whether that be on a developer's workstation, all the way to the cloud, and everything in between. whether it be the data center, whether it be a branch, or even on the edge, the 5G and the edge. This group is very focused on the data center, and that's what we want to focus on, is bringing Rancher services to IBM Z and LinuxONE, be able to do that on multiple Linux distributions. So if your favorite Linux distribution happens to not be green, you can run Rancher on other Linux distributions on Z and LinuxONE. So why Kubernetes? Because it provides a consistent set of infrastructure capabilities, whether it's API, packaging, health checks, load balancing. You can read as well as I can. The same things that you can do in the data center can be done on the edge or in the cloud. So that's really why we think that Kubernetes is so great, and why SUSE acquired Rancher at the beginning of towards the end of 2020, beginning of 2021, and because we wanted to really make a splash and focus on what customers can do in all of these areas. All right, so I think I've maybe spent enough time talking about it. Oh yeah, regarding questions, if there are questions, actually it's still working on coming up. If there are questions, I can't see the chat screen, so I've asked Bill to watch the questions and things like that, and I can take questions during the presentation as well as after. And so I quickly went through those two slides. You're getting to see the end of the server component, and again, you're going to see errors. This is the default way that Rancher Kubernetes engine deploys. Is it starts up everything and it's waiting for things to come online and become available. And here in, I'm hoping just a moment, we are going to see it come up. Now you're getting a live demonstration. This is still a work in progress. So the blog announcement that I had done was back about 2 months ago, and we have engineers already working. Okay, now you see it starting to do things. So all the services started up and it's good. So what you're seeing is actually well, you're like I said, the very first to see some of this working on S390X, and we have ourselves a working Kubernetes cluster, and I made a mistake already. I made a mistake. All right, well, we'll just kind of we'll cheat here. We'll just give me a moment. 10.128. Hang on. All right. VM Workshop RK2 server, VM Workshop -RK2 server. Okay, cat. Let's see /hosts. Okay. Okay, we're going to go back to my other notes, and here we go. Sorry about that. Sorry about this. Okay. Oh. All right. My bad. And again, I apologize. It's a little setback here, but that's okay. I can recover. All right, so at this point, we can do kubectl get nodes. I'm going to have to do one more command. No problem. Okay, so sorry, my fault for creating a problem there, but we've got our Kubernetes master up and running, and so now let's go ahead and let's add the Kubernetes a worker node. And this time I'm going to be smart about it. And screen -R. All right, there we go. RK2 dash help. So this is the RK2 dash help. Too many windows to bounce around. And okay, and then RK2 agent. But before I run the RK2 agent, I am going to need to look at a file, and this is where my cheat sheet. So again, this is still early, and so I'm showing some stuff off, and it's and you know you're like, oh man, what's going on here? But actually, what I'm trying to show here is the ability to quickly install, and even if I'm making a lot of mistakes along the way, quickly be able to install a Kubernetes environment. So now I can actually do agent. Okay. And so now this takes about a minute, and you can see again it's running the air-gapped install. So we'll just kind of watch it. And as we come over here, I'm going to switch screens to, okay, so we have only the master node at this point within Kubernetes. So, you know, there is a little bit of my demonstration. It expects people to understand a little bit about Kubernetes, and it's a master node and worker nodes. I just set up the master node, or we also call it the RKE2 server. And then the RKE2 agent is the worker node. The worker node is where containers are run and actually workloads are being run and things like that. So I can see now the agent has joined the cluster. It's not quite ready, but it'll be ready in just a moment. What I was hoping to show, in about 5 minutes, you could actually install a Kubernetes cluster using Rancher. And I'm a little over the 5-minute mark, but 5 minutes and 50 seconds, not too bad for a basic Kubernetes cluster environment that's running. Now that's just Kubernetes running. That's not actually doing anything. So let's go ahead and let's take a look at the Kubernetes cluster, and then let's actually deploy a real workload. It's a hello world that I created, but it at least give you an idea of what is set up and how this all works. So I have a number of Kubernetes pods that are running, and that's where the containers are. So I'm going to look at kubectl get deployments. -k. Okay, and these are all automatically set up as part of the default RKE2 server deployment. I also have some namespaces. And so these are all the namespaces. Some of them are internal to the kube Rancher configuration. The default one is the one that that we are going to be deploying to. If I do a get pods and I don't specify a -a, then it's going to only look in the default namespace and I have nothing there. All right, so this is how you manually interact with a Kubernetes system. You use things like kubectl and you create YAML files. And so I've got a YAML file that has a little hello world S390X that is coming from that I published to Docker Hub. We are going to kubectl and so we have I'm getting a bit of an echo there, but we've got the pod running now. Now I want to actually make this pod available to the outside world. So I'm going to go through that. Are there any questions? Maybe somebody was coming off mute to ask a question.
Is there a question out there? There was one in the chat that Mike Riggs has asked about. When you were talking about the speed, I wasn't really sure which one you were talking about here, Mike, but you said like SSI fast.
Like SSI fast.
I think when you were talking about how quickly to create or move something.
Well, no, I was talking about quickly setting up a Kubernetes cluster. I wasn't talking about any SSI related stuff. I was just talking about being able to set up a Kubernetes cluster in around 4 minutes.
Okay, yeah,
on Z.
I see now that they were talking amongst themselves, so it was a question to somebody else. Sorry about that.
No problem. Okay. All right.
I can edit that out.
No worries. No worries. That's fine. So we're going to go ahead and now make this pod available to be consumed, and again using complete command line way of doing things. /deployment, and then kubectl get. So now I've got a deployment running, and I'm going to actually expose it. And so these are all things that you would have to do if you didn't have a web-based interface to be able to work with that. I'm going to copy the expose command here. And kubectl get services. And then very last thing I will do is cat. I'll open up an ingress. I'll open up basically a port to be able to access this thing. So kubectl apply /ingress. And you just have to remember to type -f. And kubectl get ingress. All right. So now I've done all of those steps, and Kubernetes started via command line, but that's a lot of work. And so we'll talk about the web-based administration and management here in just a minute. But let me show you what I basically created, and we're going to go over here to this little web browser page, and I basically have it set up so that if I go to s390x-test.info/hello, it should say something like hello from. And then, and so that actually, I know it's not super impressive, but it is actually quite impressive that within about 6 or 7 minutes, I was able to deploy a Kubernetes master node, a Kubernetes worker node, manually via the command line, deploy a really simple Hello World application, and then make sure that Hello World application is working. But that's not the end all be all. That's cool, but that's not really what customers want. They want to be able to do it via web-based interface and things like that. And so let's go back to the presentation and quickly talk about what organizations can realize. By deploying Kubernetes, an organization can consistently deliver a high level of reliability on any infrastructure, that be on-prem, that be in the cloud, that be hybrid, that be multiple server architectures as well. And you're seeing S390X here. You're able to improve the efficiency and the interaction between IT operations and DevOps and the development folks, because what the developers develop on their workstation can be exactly the same thing that is deployed in production, whether it be in the data center or on the edge. And Kubernetes allows you to enforce security policies for that particular Kubernetes cluster, which is really good. But Kubernetes can create overhead and risk, especially if organizations are going to deploy large numbers of Kubernetes clusters. Some organizations are deploying on-prem, they're deploying in the cloud, they're deploying on x86, they're deploying on S390X, they're deploying on ARM-based processors. They're deploying all over the place, and you lose central visibility. You don't have central visibility if you use the out-of-the-box Kubernetes capabilities. If you don't have consistent security policies, it's left up to every Kubernetes implementation with regards to security, and each Kubernetes deployment must be managed independently. That's where the power of Rancher comes into play through our management. So what I've talked about up to this point is the bottom section, the certified Kubernetes distributions that can be deployed in data center, cloud, all the way to the edge. And Rancher not only can manage our own Kubernetes distributions, but we can manage other CNCF certified Kubernetes distributions. So as we move up the stack and move into the centralized management, you want to be able to do all of these things across all the Kubernetes clusters and be able to apply all of those policies and security things and all of that to all of the containerized apps, wherever they might be running, on-prem, in the cloud, in the hybrid, on the edge, whatever. Well, again, this is the power of Rancher, and yes, I started with the Kubernetes engine because that's important. You need a Kubernetes environment because everything that Rancher does is built as part of a container that is running on a Kubernetes infrastructure. But as we move from the dark blue to the light blue, where you can see on the left-hand side is Rancher, really this is the administration that I was talking about that you'd have to do individually on each Kubernetes cluster. Now you can do it via web-based interface, allowing for simplified cluster operations and infrastructure management, basic run and manage of Kubernetes systems, regardless of where they're running. But you need to tie that into security and authentication. You pick your choice. You need to be able to add policy enforcement and governance, centralized audit, monitoring, logging, benchmarking, from a security perspective, role-based access controls. And then on top of that, you need to add additional capabilities that people expect when they deploy Kubernetes within their environment, whether that be a catalog for Kubernetes applications or centralized monitoring and alerting, or you need to be able to do other things that revolve around service mesh or storage and observability. Yep.
So a question from the chat.
Okay.
Can you run a ZBSE environment in Kubernetes?
So the answer is no, because Kubernetes requires to run on Linux, at least Rancher Kubernetes. There might be other, if there is a VSE Kubernetes distribution, I'm just not aware of it. But if it's CNCF certified, Rancher can actually manage it. And CNCF is the Cloud Native Computing Foundation. That's what CNCF stands for. So it's an open standard, industry standard. Hopefully that helped.
Yes, it did. Thank you.
Yep, you're welcome. So I know I'm running through this very quickly. You probably well, if you've met me in person, you probably can tell I'm smiling from ear to ear. I've been talking about this, wanting to do something like this for a really long time. I'm finally being able to show it. I wish I was actually in a real room demonstrating this stuff to you, but we'll have to do it this way for now. But I look forward to doing it in person in the future. But getting back to the presentation, so what I basically have talked about up to this point and demonstrated so far is RKE, the Rancher Kubernetes engine. It is a CNCF certified Kubernetes distribution that runs entirely within containers, within Docker containers. This is one of the core components that will be coming to Linux on Z and LinuxONE. The other component that I just finished talking about, which is the management platform, or we call the Rancher MCM, the multi-cluster manager, that's the Rancher flagship product that allows organizations to manage a disparate large number of Kubernetes clusters, regardless of where they're at. That also will be coming to Z. The final component that will be coming is Longhorn, which is persistent block storage. So you need persistent storage to back your containers and things like that. Rancher and SUSE want to provide an option. It's not the only option. There are other options for a common storage infrastructure, or CSI. If you're a Kubernetes person, you know what I'm talking about. But we want to provide a general purpose block-based persistent storage that runs on Z and takes advantage of Z-related storage, whether that be ECKD or FCP SCSI-based storage. So let me kind of wrap it up, and then I'll get to the last part of the demonstration. I talked about IT operations, and they're responsible for provisioning Kubernetes, kind of like what I just did at the beginning of my session. They maintain the central control and visibility through a tool like Rancher, providing Kubernetes as a service, basically. They can define the capacity, the scope of capacity, delegate the administration, apply the access and security policies. All of those things are done so that resources become available to the people that need those resources. And the people that initially need those resources are the developers, the DevOps, that can take advantage of those centralized resources. And I won't go through all those in the list there, but they all can run on Linux and run. Also, many of those run on Linux on Z. And the DevOps now can actually develop their code, and they can take a continuous delivery approach to deploying their applications, containerized applications. They can do canary tests, or they can do blue-green deployment testing. They can reactively auto-scale if end of the month or end of the quarter or something utilization goes up. That's the beauty of Kubernetes. Rules can be put in place to allow for auto-scaling, be able to do that reactively based on the load of the system and things. And you can read as well as the other things. So basically, tying Kubernetes and all the capabilities of Kubernetes together gives that environment that allows DevOps people, the developers, to develop something on their workstation, but be able to do that within, on the edge or in the data center. We care about the data center, but with the Rancher UI, you as the IT operations folks that are responsible for managing the Kubernetes cluster, we want to make it easier for you. We want to make it easy as point and click. So before I get to the Rancher MCM UI part of the demonstration, I think I just want to re-highlight the Rancher's unique approach. it is a multi-cluster world. You're not going to have one Kubernetes cluster. You're not going to have one Kubernetes cluster with multiple architectures. You may, but you may choose to have a Kubernetes cluster for S390X, a Kubernetes cluster for x86-64, a Kubernetes cluster for the data center, a Kubernetes cluster for the cloud, a Kubernetes cluster for the edge. Kubernetes distributions are commoditized. The value actually is in the Kubernetes management, making easy to manage all of the Kubernetes clusters that you deployed. And we believe our approach is the most open approach to providing this capability to organizations. So a lot of organizations are using it. I'll provide the slides and you'll be able to do that. I also wanted to highlight the partnership that we have with Mainline and the co-branded Kubernetes Management for Dummies document that you can see here. You can go to this URL, you can register for the guide. If you're not familiar with Kubernetes, please feel free to do it. It's a quick read. It's just like the Dummies manuals that you see for other things. Now you've got a Kubernetes Management for Dummies that you can take and read about, and you can say, oh, what was that Mike guy talking about? No, hopefully that will help answer some of it. Okay, so let's jump over to the Rancher cluster management demonstration. This is the Rancher UI that I've been talking about. And we're going to go over to here. We're going to maximize the screen. And we are going to go back to my, no, we're not going to go my cheat sheet. We are going to go to http://Rancher. All right, and there we go. And again, this is running on S390X, but it could be running on another architecture. It could be running in the cloud or whatever. This is a basic install of the Rancher UI. It actually runs within its own Kubernetes cluster. That's what you see here. We're going to take the cluster that we just set up, that I just set up in front of you, the RKE2 cluster, and we're going to go ahead and add that cluster. And we're going to take a look at a few of the things. Now, like I said, this is a work in progress. Some of the things are still being worked on by engineering. I'm working closely with engineering, providing feedback and things like that. But the Rancher multi-cluster management allows you to manage other clusters, which is what we're going to do, but it allows you to manage clusters that are running in Amazon or Azure or Google. If you want to deploy a new cluster, you'll be able to do that from existing, Linux nodes that have nothing on them. It'll do all the work for you. You also can deploy a new Kubernetes cluster in multiple areas as well. I'm going to focus on other cluster here. And we are going to call this VM-workshop. And I'm going to do create. I'm not going to go through a lot of the details. I'm just going to quickly show how this works. I'm going to copy this last line because this is still a work in progress. I'm going to have to actually do a little bit of a scripted hack that normally you wouldn't do this if this was available, publicly. But as we're working through some of this stuff, I wanted to show this at least to you very quickly. So VM-workshop.yaml. All right, and my little hack is going to be this command right here. It just made one little change within that YAML file, and that's it. I won't go through any of the details there, but let's do this and VM workshop. If I've done everything correctly, we should have in about a minute the VM workshop. So some additional pods are being added to the cluster that I just set up. And those pods are being told to check in to the multi-cluster manager. And if I've done everything correctly, as I have, you'll see that it's actually in the process of coming up. It's waiting for the API to become available. And here in a moment, it'll show active. Now, you may say, well, you see this word RKE government. RKE2, so RKE1 is the first version of the Rancher Kubernetes engine, or just normally called RKE. We're working with RKE2, also codename as the government edition, because it's focused on not at highly secure environments and things like that. So right now, that's why you see it. It's actually utilizing a relatively new version of Kubernetes. I'm going to go ahead and click on VM Workshop now that it's active, and I can get some information about the cluster itself. Now, this is where I'm going to show that it's still a work in progress. I'm going to go to Events, and you can see that we're getting some image pulled back off and image errors and things like that, because our engineers are still working on it. I've reported some of these issues and things like that. So again, this is a work in progress. You may be asking yourself, well, when is this going to be available? When can I get my hands on it? We're hoping by late fall to be able to start letting customers try this out themselves, but you'll hear more as from our product management and me and others as we get that more finalized. But let's go ahead and let's go to nodes. And as you can see, I have the Kubernetes agent as well as the Kubernetes server. I can get some information about it. I can look at the status. It does automatic checks of like disk space. Are we running out of disk space? Are we having memory related issues? Things like that. This is just a single master node and a single worker node. But it does tell me that it's running on an S390X architecture and some more version related information. It actually is running on SUSE Linux Enterprise Server 15 Service Pack 2, which is the latest.
So Mike, a question in the chat related to this, I think, is can you let us know what resources you have allocated, IFL and memory in the LPAR?
Yeah, absolutely. Absolutely. So how about I just pop over and show you? So I'm using CIC, IBM Cloud Infrastructure Center. I'll make a little plug for that. But here is my server and agent. And the server is 4 gigs of RAM, 2 IFLs, 20 gigs of disk. The agent where the containers will be running, the workload, the hello world is running, that I gave a little bit more, 8 gigs of memory, 2 processors, 20 gigs of disk. Again, want to focus on minimal, try, this is not, you'll need, there'll be some work around high availability that we need to do, but this is the first demonstration where I wanted to show, hey, this is the minimal configuration you can work with, and then you can grow it to become more highly available. You can cluster the master node so that the control plane doesn't go down. You can actually have multiple worker nodes spread across multiple LPARs or KVM environments or ZVM environments. Hopefully that helped answer some of those questions.
Yes, thank you.
Mm-hmm. And again, you saw me typing some of those kubectl commands, kubectl get namespace. Well, I don't have to do that with the web UI, and I can actually jump from project or Kubernetes cluster to Kubernetes cluster. In this case, I only have 2 Kubernetes cluster, but with Rancher and with the latest version of Rancher that's coming out, we'll be able to manage thousands of Kubernetes clusters, whether that be in the data center or on the edge. So with that, I think I'm done. And I'm 1 minute over. I apologize. Are there any other questions? I'd love to answer whatever questions anybody has.
So a follow-up question in the chat, is this 2 virtual CPU per guest with SMT2 so that you have 2 IFLs total or something else?
So it is two virtual CPUs. So it's ZVM that it's running on, and it's basically two CPUs without SMT enabled.
Okay, thank you.
Mm-hmm. I would probably recommend we'd want to do real SMT enablement and all that kind of stuff, but I haven't enabled SMT in this ZVM environment. It's a ZVM 7.1 environment, and I just haven't taken the time to get that enabled. So,
No worries.
yep. Okay.
Anything else for Mike? All right. Well, thank you very much, Mike. We appreciate you coming on here and or wherever you are, presenting stuff and sharing us brand new stuff. Hopefully, we'll see you next year.
Absolutely. Absolutely. I look forward to seeing everybody's faces next year versus talking to a screen. But I absolutely do appreciate the opportunity to present Rancher, which is new, which is coming, and we're super excited about it. So if you have any other questions, feel free to reach out to me. And thanks again, Bill.